Okay, now that equation, W over MPL equal to C over MPK is actually really important, right? This is the profit maximizing condition. Profit maximizing condition, right? This is an incredibly important thing. So profits are maximized when this is true. Okay, so this is important, and we'll come to criticisms in a little bit. Okay, what it's saying is, if you think about it, let's look at the left-hand side. So wage, so the cost of adding one more unit of labor, divided by the marginal productivity of that additional unit. This is basically saying that this side here is the added cost of producing one more unit. So the added cost of producing one more unit by increasing labor. Okay, that's this. And analogously, this is the added cost of producing one more unit using only capital. Okay, and what it's saying is that the added cost of producing one more unit using labor is exactly equal to the added cost of producing one more unit using labor. Okay, so let's think about this. Let's think about it in an intuitive way. Let's say that the marginal cost of expanding output by 1 using labor. Okay, so let's say W over MPL is equal to 10. Okay, and that C over MPK is equal to 12. Okay, so what we're saying is we can increase output using labor at a cost of 10, or we can increase output by 1 using capital by 12. What we can actually do is produce the exact same amount of this good for less. Okay, and here's how I can do it. I can get rid of one machine, right, which will save me $12. Okay, and I can hire one more worker, which will add. So if I get rid of one unit of production from machines, right? So if I decrease this by 1, if I fire the requisite number of machines to decrease my production by 1, I'll save $12. Okay, so I'm going to decrease my capital such that I produce 1 unit less. Right, that'll save me $12, and I can increase my labor such that it'll add one more unit to my production. That'll cost me 10. So I've just saved $12 and spent 10, which means I've saved $2. And I'm still producing the same number of the good. Right? So let's say I'm producing 1,000 units. Right? I can cut my machines such that I produce 999 machines, or 999 units, and I would save $12. And then I can increase my labor such that I produce 1,000 again, and it would only cost me 10. Right? So I've just saved the company $2, which is kind of cool. And so you can play with that, right? If you could play with that in the real world, if we assume that you can have fractions of units, etc. So I don't have to increase by 1, but maybe I could increase by like a half instead of by 1, right? We could increase by fractions of units here and there, and we would continue to do such an exercise, hiring fewer machines and more workers until they equaled, right? So if marginal productivity, or if C over MPK is higher than MP or W over MPL, we want to reduce K and raise L, okay? And we want to do that until they're exactly equal.